guns which emits red, green, blue light respectively, and they are packed together in strips or clusters called triads. The color CRT have 3 electron guns, one for each primary color, and arranged either in a straight line or in equilateral triangle configuration. We have 3 electron guns, it can be in a straight configuration or it can be in an equilateral triangle configuration, right. So, a grill or mask absorbs electron that would otherwise hit the wrong phosphorus. Shadow mask tube uses a metal plate with tiny holes. It is a tube uses a metal plate with tiny holes placed so that electron beam only illuminates the correct phosphorus on the face of tube. Another type of color CRT uses aperture grill to achieve the same result. Suppose we have a 3 electron guns which are emitting red, green and blue electron beams, and in the screen we have a triad, we have a dots of different colors. So, the our purpose is only is that the red color will strike to red dot and blue colors electron beam strike to blue dot. For this purpose we use a shadow mask, or we can use aperture grill also. Another, we have talked about phosphorus persistence. Various phosphorus are available depending on the need of measurement and display application. The brightness, color and persistence of illumination depends on the type of phosphorus used on the CRT screen. Thus, phosphorus are available with persistence ranging less than 1 microsecond to several microseconds. Persistence, it is the term related that how much time the display is there, illumination is there. We are talking about phosphorescence, that is the light is emitting and falling in visible range. So, how long it persists, how long it is there, it terms in terms of phosphorus persistence. Then we have microchannel plate. When displaying fast one shot event, the electron gun must deflect very quickly with few electrons impinging on the screen, leading to a faint or invisible image on display. So, oscilloscope CRT designed for very fast signal can give brighter display by passing electron beam through microchannel plate just before it reaches the screen through the phenomena of secondary emission. This plate multiplies the number of electrons reaching the phosphorus screen and giving a significant improvement in writing rate and improve the sensitivity and spot size as well. Then graticules. Most all oscilloscope have graticule as a part of visual display to facilitate measurement. The graticule may be permanently marked inside the face of CRT, or it may be a transparent external plate made up of glass or a cyclic plastic. An internal graticule eliminates parallax error. Parallax error, if we see, uh, this error occurs when we view something from a certain angle. When we are viewing certain image from a certain angle, it gets blurred. We are not having a clear image. So, to avoid this parallax error, we use this. This is in color monitors. We have talked about that we have 3 electron guns for primary colors red, blue and green. Then we have a shadow mask, which is a plate having holes from which various electron beams are passing through and striking on the corresponding color on the screen. Then there is also a need of convergence and purity magnets in color CRTs. The need of convergence and purity magnet is that the shadow mask ensures that one beam will only hit spots certain color of phosphorus, but minute variation in physical alignment of internal parts of individual CRT will cause variation in exact alignment of beam through the shadow mask, allowing some electrons from this. For example, red beam to hit say blue phosphorus unless some individual compensation is made, means as we need that only red electron beam strike to red dot on the screen. For this we use convergence magnet and purity magnet. Convergence means to converge in a single direction to avoid scattering. So the convergence magnet and purity magnet provides the facility that only red beam electron beam strike to its corresponding red spot on the screen without diverging from other color, say blue or say green. Color convergence and color purity are two aspects of this single problem. Firstly, for correct color rendering, it is necessary that regardless of where the beams are deflected on the screen, they hit on the same spot, right, on the shadow mask. This is called convergence. More specifically, the convergence at the center of the screen is called static convergence, and the convergence over the rest of screen area is called dynamic convergence. The mean may converge at the center of the screen and yet stray from each other as they are deflected towards the edges. Such a CRT would said to be have a good static convergence but poor dynamic convergence. Then problem of existing in color monitors. Up till here we have discussed various parts of color monitors CRTs. We have discussed various function of magnets, shadow mask. Now what are the problems existing in the color monitor? First problem is degaussing. Degaussing means if shadow mask becomes magnetized, its magnetic field deflects the electron beam passing through it, causing color purity distortion as beam bend through the mask holes and hit some phosphorus of color other than that which they are intended to strike. For example, some electrons from the red beam may hit blue phosphorus, give pure red parts of image as a magenta tint. So, this effect is localized to a specific area of a screen if the magnetization of shadow mask is localized. So, therefore, it is very important that the shadow mask is unmagnetized. So, this is the problem which is existing in color monitors over the time, that is magnetization of the shadow mask. If your shadow mask is magnetized means you are losing the color purity in your monitors. So, solution of this problem is that most color CRT display, that is television sets and computer monitors, each have a built-in degaussing demagnetizing circuit, the primary component of which is a degaussing coil which is mounted around the perimeter of CRT face inside the bezel. Upon power up of CRT display, the degaussing circuit produces a brief alternating current through the degaussing coil which smoothly decays in strength to 0 over a period of few seconds and producing a decaying alternating magnetic field from the coil. The degaussing circuit is often built up of thermoelectric device containing a small ceramic heating element and a positive thermal coefficient resistor connected to the switch of AC power line. Resistor is this in the series of degaussing coil. When power is switched off, heating element heats up the PTC resistor and it increases its resistance to a point where degaussing current is minimum, but not actually 0. To repeat to a reset degaussing circuit, allowing PTC resistor to cool to ambient temperature and switching the display off immediately back on will result in a weak degaussing cycle and effectively non degaussing cycle. Here the problem is demagnetizing the circuit. For demagnetizing the circuit, we are using a thermoelectric device which is connected with a heating element. The main purpose of this, as the current rises, its resistance becomes 0. To make it 0 or make it very minimum, or when its resistance is increasing, current is becoming very 0, and we are cooling PTC resistor to cool to a ambient temperature, which allow the demagnetization of the coil. Now monitor specification, pixel specification. A pixel, short for picture element, using common abbreviation pix for picture, is one of the many tiny dots make the representation of the computer screen, right. Then pixel resolution, if we say pixel resolution, the term resolution is often used as a pixel count in digital imaging, even in America, Japan and international standards, and an image of n pixels high by m pixels wide. This is the height and width, n by m pixel. So this is the resolution, pixel resolution. If we say 640 by 480, means it is 640 in height and 480 in width. Then about the refreshing rate. What is the refreshing rate and why it is important? For refreshing rate is important. An image appear on the screen when electron beams strike on the surface of screen in a zigzag pattern. A refresh rate is the number of times a screen is redrawn in 1 second, and it is measured in hertz. Therefore, a monitor with a refresh rate of 85 hertz is redrawn in 85 times per second. A monitor should be flicker free, meaning that image is redrawn quickly enough so that user can't detect flicker. A source of eye strain. Today, refresh rate of 75 hertz or above is considered to be flicker free. Then this is the refreshing of CRT as we have done. Then what is the resolution? Maximum number of the points on which we can display it on the CRT. Refreshing rate is the frequency at which a picture is redrawn on the screen is referred to refreshing rate. Then we have two types of scanning techniques, raster scanning techniques and random scanning techniques. Then in case of, this is the raster scanning techniques, which is started from very light left corner to the right and moving from top to bottom. This is the pixel size on the screen, raster scan, and picture information stored in refresh frame buffer. This is the frame buffer using like 8 bits per pixel, which is corresponding to 256 to the raised power 8, that is 256 simultaneous color. So this is the bit level or monochrome display having 1 bit per pixel. This is the depth of color. Then another technique of scanning is random scanning technique. In random scanning technique, calligraphic display, also called vector or stroke or line drawing graphics. Electron beam directed only to the point of picture to be displayed. Vector display, electron beam trace out lines to generate pictures. This is the random scan display principle, means at any point you can focus your electron beam to draw any image. This is the comparison, and after the merits of CRT monitors, disadvantage of CRT monitor is eye strain, size, high power consumption, and advantage is quality is good, darker blacks, and as a result better contrast ratio, better color, better viewing angles, than most LCDs and faster response times than LCDs, multiple native resolutions. Then what additional feature we can add, that is power saving feature we can add, integrated accessories we can add in CRTs. Then harmful effects of CRTs, that is ionizing radiation, as we have discussed in CRT can emit small amount of X-rays radiation. As a result, electron beam bombarded on the shadow mask. Then toxicity, this is also the material used, toxic material uses as a cadmium or leaded glass, which is also very harmful to the environment. Then flicker noise, which is another harmful effect of CRTs. Then recycling is very important factor, that it is very difficult to recycle, as electronic waste CRT considered to be one of the hardest type to recycle. So CRT have relatively high concentration of lead and phosphorus. So both are necessary for the display, but these two factors are these two metals are very difficult to recycle. So it is very difficult to recycle CRT material. Another in a LCD display we have discussed, we can add glossy display, we can have stereo display also, touch screen feature we can add, graphic tablets and screen hybrid, the future upgradation we can add. These are the manufacturer Acer, AOC, BenQ, LG, NIC, Philips, Samsung. These are the various manufacturers of various monitors. And future scope of CRT technology, that we can have flat panel LCDs, rear projection plasma displays, or we can have slimmer CRTs also, which is are shown in the diagram. And we have flat panel displays also, in which we have plasma display, we have LCD displays, which are mostly used nowadays. So these are the main concepts in the flat panel display. Thank you.